Hello everyone, welcome to another maths challenge question. This one looks simple but difficult at the same time, so let's have a read of it together. Two identical 1x2 rectangles overlap as in the figure on the right. What is the area of the common shaded part? On the surface this looks really easy, but I think it might be a bit more difficult when people actually get stuck into the question. So have a go at it, pause the video, and we'll go through it together afterwards. Cool, so let's have a go at this question. I think I'm going to draw this out first, and then I can label the diagram. So we've got these two rectangles, which are identical. Cool. There we go. Again, I'm not an artist, so it's not perfect, but it's good enough. Okay, so I know some information. I know the dimensions of each rectangle. It's 1x2. So this length here is 1, and this entire length here is 2. Now, one thing we need to think about is how would we find the area of this shaded region? Because it's not the nicest shape in the world. If it was a square, it would be very easy. It would be base times height. But we have this unusual looking parallelogram. Well, one thing you can note is that if we were to split the shaded region, like so, and we were to move this triangle, this shaded triangle, to the left, this triangle would actually be the same size as this triangle. We know this due to the symmetry of this question. Since this rectangle here is just a rotation of this rectangle, we can actually split this in half, and it's a reflection. Therefore, this triangle will be the same size as this triangle. If we were to move this triangle here, then we have a rectangle, which is easy to find the area of. We just need this length times by this height. And we already know that the height is 1. So in other words, we need to find this length here. Cool, let's call that length L. That's the length we need to find. Now this whole length here is 2, so therefore this length here is 2 minus L. Okay, that's useful. Now what we have here is we have a right angled triangle, this one here. And since, like I said before, this shape is symmetrical about this line here, that means this triangle here is congruent to this triangle here. Therefore, this length must be the same as this length here. So we've just found that this right angled triangle has a hypotenuse of L. Nice. Now, whenever you're working with right angled triangles with lengths, it's a good idea to use Pythagoras theorem. Pythagoras theorem states that a squared plus b squared equals c squared, where c is the length of the hypotenuse and a and b are the lengths of the other two sides. Cool. So we know that 2 minus L all squared plus 1 squared equals L squared. So now we just have to rearrange this and get L by itself. So first let's expand this bracket here. 2 minus L squared, that's going to get us 4 minus 4L plus L squared. Then we've got plus 1 squared, so plus 1. This equals L squared. Cool. We can actually see that the L squareds are going to cancel with each other. Cool, so let's move the 4L to the right hand side and combine any constants together. So 4 plus 1 is 5. This is going to equal 4L. So what does L equal by itself? It equals 5 over 4. To find the area of our rectangle, we just need this length times by this length. But this length is just 1. Therefore, the area of our shaded region is just going to equal 5 over 4. And that is A. So A is our solution, and we're done. I hope you enjoyed the question, and I'll see you in the next video. Bye bye.